So, welcome to this online course on artificial intelligence search methods for problem solving. Now, this course has been running for quite a few years and we have had quite a few participants in this course, but since the last recording was done about 5-6 years ago, we have started with some fresh recordings, because things have changed a little bit and also we have made certain things more explicit essentially. This recording that I am doing is in this very difficult times, in the times of coronavirus, and you can see that I had a mask which I used when I came here, and so I hope you are all protecting yourself well as well essentially. Okay. So, what we will begin with now is an introduction to the course, which I have called as a prologue, because there is a longer introduction which we recorded the last time, which consisted of the history of AI and the philosophical aspects and things like that, and that has not changed too much. So, we will just reuse some videos there. In this video, I will introduce you to some of the changes that have happened in the last 5-6 years, because AI, as you probably know, has become a buzzword in the last couple of decades and especially in more recent times, and we will look at some of the issues that are there. After which we will do about 5 videos of history and philosophy, which are carried over from the last recording of this course. And when it comes to the technical matter, the entire course is re-recorded. This time I have used slides and animations and to talk about the subjects, as compared to the last time when I was teaching a live class and we had lessons on the blackboard and we had students interacting. So, let us begin with this first talk, which I have called as a prologue, because it has been recorded in some sense after the rest of the slides have been recorded, and this kind of puts the whole thing in picture essentially. So, we begin with the basic idea that our goal in AI is to build intelligent agents. And what are intelligent agents? Intelligent agents are essentially programs as far as we are concerned. The programs may be residing in physical entities like autonomous cars or robots, physical robots or spacecraft or all kinds of things, all kinds of machinery that we use. But our interest is in the programs which control those machines essentially, and we will use the term agents and programs synonymously. And agents are essentially programs which are persistent, which means they are alive all the time, which are running all the time, unlike most other programs where you say you run this program and then you get the output. It is not like that. These programs are running all the time. They are autonomous, that they do not take too much input from the users, and they, unless of course, there is some activity in which input is required, but otherwise they run by themselves. They are proactive, they make their own decisions that have to be made, and they are goal directed, in the sense that they have certain objectives that have to be met essentially. Typically, these objectives are given to these programs by the users essentially. So, an intelligent agent in a world carries a model of the world. So, if you have to reason about the world that you are operating in, whether it is a physical world or whether it is a cyber world or whatever the case may be, you have to represent it in some way. Some people call this as domain representation. We will just say, use the term that we carry a model of the world in which you are operating, and this model of course may be an abstraction. You cannot capture the real world in its entire detail. So, it is always abstraction. Models are always abstractions, and the abstraction is done based on what is the purpose that you want to achieve. Now, one thing in AI is that we do not often write programs for a specific task. So, there is an entire world which needs to be explored, this entire area of knowledge representation which has to be explored, which is still in its infancy, but we will not get too much into that. We are more concerned with problem solving here, and what we would assume is that an agent, a self aware agent would make a model of the world, and it would also have a model of itself in the model of the world. So, for example, if this is the world and this is the agent in the world, then inside the agent's head, if you want to call it the head, is a model. As you can see, the model in this case is an ellipse, which is not quite the original world that it is representing, but it is an abstraction, it is a model, and inside that model it may have a model of itself essentially. So, there are areas where in multi agent systems, in areas where for example, humans have to interact with robots, the agent should be knowing that it is there in the world in which activity is happening, and it should be able to reason about its own actions and actions of other people. The information processing view of AI, which has been around since the beginning of AI, is that we sense a signal. So, for example, as human beings we have eyes and we have ears and our nose and our sense of touch and things like that, and what we get from the outside world is a signal, and at the inner core of thinking, of cognition, of reasoning is what we call as symbolic reasoning essentially. Our concern in this course is on symbolic reasoning, but to interact with the outside world we have to convert the signal into symbol, and very often this is done by neuro fuzzy systems. So, for example, neural networks are an example which can for example, recognize characters, recognize people, recognize faces, recognize objects and things like that. So, that once we know what are the objects we are talking about, we can work with them at a symbolic level. So, the whole process is a layered architecture. At the outermost layer we do signal processing, then the signals are converted into symbols using a neuro fuzzy process, and whatever decisions that you take, they are again actuated in some form. For example, you may move an arm, a robot may go from one place to another, or you may show certain graphics on a screen, and so again we produce signals essentially. Okay. So, it is you start with signals, you process, convert them into symbols, do the reasoning, generate the desired output and send the output out as signals. So, that is generally the information processing view of AI. This is something that we will revisit when we talk of the introduction that was recorded 5-6 years ago, and AI is a very broad field. It contains many areas as of now. So, this diagram is supposed to go together with the previous diagram. Previous diagram, if you remember, we had the signals coming in from the left and the actions going out on the right. So, we follow the same topology here, and we assume that all the activity which is to do with signal processing is shown on the left side of the screen. So, speech processing, image processing, computer vision, neural networks, pattern recognition, all this stuff is in some sense part of AI nowadays, and in the circle inside here is what we call as the cognitive activities, the thinking activities, the reasoning activities and so on, and that is the focus of symbolic AI. It itself has many areas. So, it has things like qualitative reasoning, knowledge representation, ontology and so on and so forth, and what we are seeing here in red are the things that we will cover in this course. So, the title of the course itself says problem solving using search methods. So, these two are the topics which are there, but there are other things that we will look at, for example, planning and constraints and adversarial reasoning, which means multi agent reasoning or games as far as we are concerned, and a little bit of logic essentially. This is the second edition of the course. As I said, we have already been running this course, but much has changed since 2013-14 when I recorded the lectures last time. And what has happened is that there has been an explosion of the amount of data that has been available to machines, and advancements in neural network architecture, training algorithms, and somehow it has created this impression among some people that that is all there is to AI, that neural networks or deep neural networks or deep learning or data science is all there to AI. We will briefly look at this picture just to put everything into perspective, and I must repeat again that this is not the subject matter of this course. This course is to do with symbolic reasoning. I am just trying to highlight the fact that symbolic reasoning is an essential core component of AI. So, we briefly look at this what has been happening in the last 6 odd years or since we last recorded the introduction, and we will kind of comment on that a little bit. And so, in that sense this is the second edition of the course that we are doing essentially. Now, coming back to this the cognitive architecture, if you are thinking of human beings, which is kind of suggested by the fact that we have a human face drawn here. Most of the cognitive activity, most of the thing that we ascribe humans to be intelligent, or we say that humans are thinking creatures, are all contained in the inner core of symbolic reasoning. So, the topics that we can see here, logic, knowledge representation, ontology, semantics, natural language understanding, memory, search, problem solving, planning, models, all this is part of the inner core of symbolic reasoning, where everything is represented using symbols. We will look at this whole idea of symbols and the physical symbol system hypothesis, which Newell and Simon had given in the introduction, which will follow this lecture. So, I am just trying to put everything into perspective here. In human beings, the inner core is the most prominent, as kind of suggested by this figure, whereas the perceptive activities of signal processing and neurofuzzy processing for human beings is not the prime consumer of our energies or cognitive energies, if you want to use the term like that. Now, on the other hand, what has happened in the real world, thanks to the explosion in the internet, the fact that we have big fat companies which we interact with, that they give us tools to interact with other people. We have social media, we have Google, Facebook, Amazon, all kinds of centralized entities which we interact with in order to interact with the rest of the world. So, if you are talking to somebody on WhatsApp, Facebook is aware that you are talking to somebody in WhatsApp. So, all these companies are very keen to figure out what are you doing, where are you going, who are you talking to, what are the kind of websites you are visiting, what are the kind of things you are buying, and all this kind of stuff. So, that is kind of illustrated in this diagram, that you see millions of eyeballs which are interacting with this kind of intelligence. But what this kind of intelligence is doing is essentially data processing, data science, some people call it machine intelligence. So, it is doing things like using neural networks to figure out what you are looking at, labeling images and all this kind of stuff. So, what is happening in the world of machine learning and data science is largely neuro-fuzzy processing. The internal core is still very tiny, they are not able to reason symbolically, and we will kind of talk about that a little bit in this talk here. So, that is a difference between what is happening with humans. We have a large core of symbolic reasoning, whereas machines are prominently doing neuro-fuzzy reasoning when they are processing tons and tons of data essentially. So, we can at this point distinguish a little bit between artificial intelligence and machine learning, though of course, machine learning is a part of artificial intelligence, because nowadays we use the term artificial for almost everything that machines do, including making sense of data, which is what I would like to call as machine learning. So, machine learning is essentially making sense of data, whereas what we call as AI, or some people call as good old fashioned AI, GOFAI, good old fashioned AI, is to do with knowledge representation, reasoning, problem solving, and things like that essentially. So, we will, at least in this course, when we talk about AI, we would mean this symbolic AI or good old fashioned AI, whereas machine learning is making sense of data. So, either you have lots of data and you extract some information from it. So, for example, recommender systems, they, if you are buying stuff on Amazon, on Flipkart or something, they are watching what you are buying essentially, and then they are trying to see, okay, persons who bought this book, for example, also bought that other book essentially. So, they are trying to make sense of the data that they are gathering from you. Remember this figure that we talked about, millions of eyeballs. So, You can imagine this circle here is Flipkart or Amazon or Google or whatever is your favorite web source, and they are looking at what you are doing and they want to make sense of what you are doing largely and to kind of drive the advertisement, but sometimes they do other nefarious, more nefarious things as well essentially. So, that is one side of machine learning, which is making sense of data, looking at data and trying to extract information from it. Another sense is classification, which is also trying to extract information from data, but it is more specific in the sense that you want to give a class label to things. You are looking at an image and you are saying this is an image of a horse in a meadow. So, you should be able to label it by saying that this is the kind of image that we are talking about, or that this is an image of traffic in a urban environment. So, these kind of labels, which of course, they originally get from human beings, because human beings are constantly labeling images on Instagram and Facebook and all kinds of places where we share images. What these programs are doing is harnessing those shared images and learning from them. So, the kind of learning they are doing is classification, that they can look at a new image and they can produce a class label, which is consistent with what they have seen in the past essentially. And largely deep learning, which has been the buzzword in the last 10 years, has been successful with image labeling and language and so on and so forth, language processing. So, here is an example, just one example amongst many, where deep learning, neural networks, classification have been a tremendous amount of success essentially. Okay. So, this is a example of one such application which was developed for the mobile phone called face to gene, and it is being used by doctors to diagnose real diseases, rare diseases. What happens that supposing you have a child who is suffering from let us say the Mowat Wilson syndrome, and but you do not know, of course, not every doctor is an expert in every specific rare diagnosis. What machines can do is they can harness the information provided by thousands of doctors all over the world who are looking at images like this and saying, yeah, this is this disease or this is this syndrome and things like that, and learning from that. So, this application called face to gene, you take a picture of your child and upload it onto this app, and immediately it will give you a diagnosis about what the child is suffering from or not suffering from, as the case may be. Now, you can see that this is a tremendous advantage for humankind, the ability to arrive at quick diagnosis, and it has been one of the greatest successes of machine learning essentially. So, in the beginning of this year 2020, there was news from UK that machines have become better at identifying breast cancer than human experts essentially. Why is this possible? It is possible because these machines are making use of the data which has been extracted or culled out of the diagnosis given by thousands of doctors, and machines can learn from that essentially. So, obviously, it is a great advantage, and in fact, I would go so far as to say that diagnosis is probably the biggest payoff that machine learning is given to humans, but there are others as well. Now, since we want to kind of emphasize the fact that diagnosis or classification or data processing is not everything that is there to AI, we are just looking at what may be missing from AI here. So, many people have observed, Stuart Russell for example, that while machine learning is powerful, and you would do well to look at the diagram which I have reproduced here on the top right, which kind of says that that machine learning or neurofuzzy processing is the largest core of most current systems, and of course, they can do things like diagnosis and image labeling and language processing as well. For example, Alexa does it all the time, but what they do and many people have observed this, is that everything machine learning does now, humans do in a blink of an eye. A doctor has to simply look at an image and be able to say that it is a case of cancer or not. The doctor does not take much time to do that. Of course, machines also are becoming faster and faster, but they have to go through a process of training for every specific example. We will see that essentially. So, here is a nice article which I read on communications of ACM, appeared in 2018, and it talks about the differences between human level intelligence and animal level abilities. So, I am giving you a few quotes. These quotes are not necessarily from this author, but other people also. For example, Julia Pearl, who has been well known, he got the Turing Award for his work on causality, has also been talking about things like that. And so, he has said, for example, that eagles and snakes have better vision systems than human beings. We are trying to contrast with what animals can do, what machines are doing, and what humans are considered to be intelligent for essentially. So, eagles and snakes have better vision systems. We know that eagles can spot a prey from high up in the sky. Cats have superior navigation abilities. You can leave a cat somewhere and it can find its way home quite easily. Dogs recognize and react to human speech as well as humans do. Sometimes maybe perhaps even more, they are more sensitive to your emotions, and I mean if you have a relationship with the dog, if the dog is your pet and so on. African grey parrots can mimic human speech. So, it is not just that humans can speak, and of course, machines can speak. For example, Alexa probably speaks to you if you have one at home, but parrots can also do that essentially. Yet none of these animals have the cognitive abilities and the intelligence that is typically attributed to humans. So, what we are trying to do is to kind of step back a little bit and say, okay, fine, we are doing a lot of machine learning and it is a great success, and almost everyone wants to do machine learning, but there is more to intelligence than classification, there is more to intelligence than pattern recognition and things like that, data processing. Now, Rodney Brooks, who is also a well known person in AI, he wrote this article called the 7 deadly sins of AI predictions in the MIT Technology Review. He compares performances versus competencies. So, performance versus competence. So, he says, now supposing a person tells us that a particular photo shows people playing frisbee in the park. So, when human beings talk about people playing frisbee in the park, we create a much larger picture. We naturally assume that a person can answer questions like what is the shape of a frisbee. So, those of you who have come into contact with the frisbee or seen a frisbee would know that roughly how far can a person throw a frisbee, can a person eat a frisbee. Of course, we can't, but we can answer these questions essentially. I mean we can't eat the frisbee, but we can answer the question whether a person can eat a frisbee or not. Whereas, computers can label images by saying putting a label that people playing frisbee in a park, but they have no chance of answering the kind of questions that we have indicated here, that what is the shape of a frisbee, how far can you typically throw a frisbee. And the reason for that is that they have no idea what a person is, they have no idea what parks are, that they are usually outside, that people have ages, there are young people and old people, the weather and so on, all kinds of things we know, and we can reason in the context of that. So, as I said, creating a model of the world in which you are operating in is a goal that AI is working towards, but we are still some distance away from doing it at a general level. Also quoted by Rodney Brooks is Marvin Minsky. He said that there are certain words which he called as suitcase words essentially, that they carry a variety of meanings. So, they are like suitcases, in which you can pack many different meanings essentially. And he said learning, which is of course, the big thing in the last 10 years in AI, is a powerful suitcase word. He says it can refer to so many different types of experience. When people hear that machine learning is making great strides in some new domain, they tend to use as a mental model the way in which a person would learn in that new domain essentially. However, machine learning is very brittle, and Marvin Minsky is saying that. And it requires a lot of preparation by human researchers or engineers, special purpose coding, special purpose sets of training data, and a custom learning structure for each new problem domain essentially. Whereas, what we are interested in is even when we are interested in learning, we are interested in general learning. When we are interested in AI, we are called interested in general AI essentially. Okay. So, one has to kind of distinguish between what is useful and what is academically interesting essentially. So, many programs which can do classification may be very useful, but they may be using the same kind of network architecture. In fact, they may be using the software provided for example, by Google to train neural networks and doing a new task essentially. So, that is a different kind of achievement. It may be very useful, but does not necessarily make advancements into AI in the sense that we want to produce thinking machines essentially. Okay. Because that was the original goal of AI, and as we will discuss that in the next 4 or 5 lectures when we talk about history of AI and the philosophical aspects of AI as well. Another great achievement in the last few years was in this game called Go. Now, those of you who have followed this, and we will again look at the introduction in this, we will see that computer games and especially games like chess and checkers and Go have always fascinated human beings, because human beings are find this as a challenging task to play this game essentially, and sometimes people used to say that if you can play good chess, you must be intelligent and that kind of thing. But in 1997 when IBM's Deep Blue program beat Kasparov, then people are saying, oh, it is just a program, it is following the same old some predefined rules and things like that. So, we start disassociating intelligence with games like chess, but Go was still considered to be a much harder game. So, as you can see from this diagram here, the board is in the center, it is a brown colored board, and at every intersection, for example, here you could have placed a coin essentially, and the dimension of this board is 25 by 25, which means that the number of choices available to any player is very large. So, you can place a coin on any one of 25 into 25 available places. And so, we thought that Go is much harder to play, and people used to associate the fact that it is popular in the eastern part of the world, especially in Korea and Japan and so on, and perhaps that they have a different approach to thinking, which is kind of tied up to Zen or Zen Buddhism, and maybe they are doing a different kind of thinking based more on perception and less on reasoning and things like that. So, we used to think that Go is a hard game, and until of course, this company which was at that point in the UK, company called DeepMind, with a team of 25 odd engineers, they kind of worked hard over a few years to produce this program, which finally beat the world champion Lee Sedol, whose picture is shown on the right, in 2016, and it created a great uproar and a lot of publicity for AI. In fact, DeepMind went ahead and made a film on this topic, and if you can get your hands on the film, you can see that it's like a gripping feature film essentially. Not only that, AlphaGo of course learnt by studying the games of other experts, human experts and so on, but pretty soon they came up with a new algorithm called AlphaGo 0, in which all this experience that they were learning from was no longer required, and all you had to do was to give the rules of the game to the machine, and the machine would play against itself repeatedly, and you can imagine that machines are fast and they can play millions of games against itself, and through a process which is called as reinforcement learning, it could figure out what are the best strategies to play. So, it turns out that in 2017 AlphaGo 0 comprehensively beat AlphaGo not only in Go, but also in chess essentially. So, learning of course has its plus points, provided that you are working in a well defined domain, and chess and Go are pretty well defined domains. Now, we often confuse nowadays automation with AI, and I would like to kind of emphasize here that they are quite different creatures and all. When we talk about AI, we want to talk about intelligent machines, we want to talk about logic and reasoning and semantics and representation and so on. We also want to talk about machine learning, deep learning, language processing and so on, and we also want to talk about data processing, because machine learning works from data. So, if you want to build an algorithm to learn a decision tree, you have to learn from training examples. So, data is the key there, but automation is a totally different cup of tea together essentially. I mean, you have things which have nothing to do with AI, things like train reservation, online shopping, travel planning. Travel planning may have a little bit of influence from AI, vending machines, harvesting machines and so on and so forth, but also that a lot of automation benefits for machine learning and data science, especially things like self driving cars, because they have to learn to recognize images and do path planning and things like that. So, I just want to in this slide differentiate between these different terms which are so popular nowadays: machine learning, AI, data science and automation essentially. Our focus is again on the left part of the screen, which is AI or symbolic AI.